Welcome back, friends. We have been breaking the code, cracking the code in this different situations. For example, the encoder transposition encoder being no change or being given or swap. In this video, we'll just extend that logic just a little bit to crack the code, even when the enemy is randomly choosing what it is doing. So, enemy is being quite smart, but we can be one step ahead of the enemy and, in fact, always crack the code. Let's just see what we are dealing with here. Remember, the enemy encoder is a plain text message Python plus some string plus some secret code, that is, which is going through one of these four, just that we do not know what it is. Additionally, it's going through a Caesar zipper. Again, we do not know how much is the shift. We are observing this, but can we crack this? In fact, the answer is yes. We already know what we are going to do. We have seen this for no change, for even or swap. We are now just going to include these two, and the philosophy is very simple. Remember, we are using a brute force approach, which means that we are trying every possible shift on the cipher. We can likewise try each of these and try to see which of these gives us that string Python in the first six characters. Whichever gives us this Python is indeed the encoding used, and all these encodings are self-decoding. So I can just call the function once again to decode them. But of course, you can generalize this activity quite a bit, where the decoding algorithm itself has to be, is substantial. But in which case, you have to, build that decoding algorithm. But the idea remains the same. So let's just go back to the code and build this now. Now, previously, remember, we have tried encoder 0, encoder 1. Now, let's say I do not do this. So let enemy pick up the random encoder. I expect it to kind of sometimes work, sometimes not work right now, because I'm only searching for, no change or even odd swap. So this time it worked, and indeed the code was no change because I do see a Python over here. But like I said, I'm just going to be, brute force here. So instead of just EO, I'm going to say MSG, say decode R, and I'm going to call this a reverse, so MSG underscore tech, because this is a reversal. And I'm going to try one more, which is say MSG decode, say middle swap MS, and I'm going to call it say swap middle, let's say, say MSG deck. Now, let's just print these as well so that we know what's going on. So I'm just going to say MSGR and say so it just be MSG DCR and MSG DC underscore, let's say MS. We can make this a little bit bigger. Probably I'll need more space here though. But nonetheless, I can probably move this as well a little bit. And now, instead of just looking for deck or say EO, I can just copy this entire condition and paste it over here. Just be careful of the indentations. It should all align at the same level. But here I'm going to say if message say R is giving me Python, which means after reversal, if I see a Python, then that means it's correct. I've got the message, but this must be reverse. And again, the secret code must be taken out from this same string message decode R, and I can in fact go and paste this once again. Just be careful about the indentation, right? Because again, all these if elif must align perfectly as they are doing so here. So this time round, I can look at say message decode say ms, and if that is Python, the first six characters of that is Python, I know it's again code cracked, and I can say it's say middle swap, and again the secret code can be read off from this ms. And in fact, that's all we need. You'll find that in all situations the code will crack. uh, let's just run this. So say I run this code now, it runs, and it turns out that at 22 I did see in the no change scenario, I did see the did see this Python something, and indeed that means I managed to crack the code, and the code was this store web 6 whatever. Notice this is what I had observed, right? And let's run this a few more times. So if I run this again, now this is what I'm observing, but it turns out that the message being done was a reverse, and actually we can see that Python had become this. And also we can see it from here, because here in the reverse string I see a Python, which means that I must read the code also from here, and that's indeed whatever GHC, something like that, right? So we can run this a few more times, but in fact, the code is now ready. This time we managed to break it right in the beginning. The very first shift did it for us, and the secret code is indeed this, right? And with this, the code is in fact ready. We can just say remove this print statement because it takes up a lot of space. And with this now the code is ready, so we know it works. We know it was email not swap, and the secret code was this. So even though the enemy was quite smart, enemy tried to trick us by all this randomness, but since we knew that the first six letters of Python, that became pivotal for us to break the code, and we managed to break enemy's code by using a smart, let's say, brute force search, by by just going through every possibility out there and stopping when we indeed found the code using the break statement. So really good practice in Python programming. In this process we have touched the for loop with the if elif statement, the string slicing, and also this break statement. So I think really nice practice. I hope you found this interesting. I hope you found this enjoyable. Keep enjoying programming, keep practicing, and you'll keep getting better and better. Thank you so much. Take care. Bye bye.